Hi, everybody. Welcome in this Expert Talk webinar studio. Today, we are happy to welcome Erik Mosselaar. He is Business Development Manager at Distance. Erik, thanks for being here. And please tell us what you do at Distance and what does Distance do?
Well, thank you, Isabella. Hi, my name is Erik and I'm with Distance. We are in the business of maximizing machine health. We build solutions with cutting-edge technologies that make your rotating industrial assets last longer, produce more, and perform better. Our Condense.io solution helps your service organization and customers run more efficiently and increase asset reliability consistently. Proper lubrication is a key element in keeping rotating machinery healthy and in operation. Many online and IIoT systems claim to provide an ideal solution for lubrication, but what does this mean and where does this fit in? How should it be used? We believe that a one-size-fits-all approach does not apply. We will try to explain how we circumvent biases like this with Condense, and we offer multiple methods and combinations of these depending on need, feasibility, and desired results or objectives. Let's start with the primitive ones, where detection of improper lubrication is one of the objectives. Traditional methods like temperature or wideband noise and vibration can indicate lubrication issues. As said, these are common, however, they're primitive and detection occurs at a relatively late stage. And therefore, many asset owners turn to specialized methods like, for example, ultrasound. One emerging method for detection of such issues, especially with fluid film bearings, is the measurement of mechanical stress with force detection sensor. Based on our experience, this is a great alternative to proximity probes, especially for retrofit situations. And this technology is something to follow, and we have multiple cases on track around this to be published soon. Additionally, Condense has introduced a signal processing method to detect friction phenomena with a standard off-the-shelf vibration sensor. A sample required with a common high Fmax 10 kHz accelerometer not only shows vibration levels, but can also expose friction. Measuring the present friction is highly beneficial if one is trying to figure out an accurate or need-based greasing routine, or simply wants to confirm a successfully performed task. The lubrication indicator is only just the first development based on this method. Oil and lubrication analysis can also be a powerful tool in preventive maintenance. For example, deriving wear and tear from detecting and calculating metallic particles. In certain situations, like slowly rotating bearings, developing cage issues are only seldomly observable in lab samples. In many cases, when it is detected, it's already well progressed. And for example, in case of water leakage, the wear process starts within hours after water reaches the oil. So we are likely to see the symptom and not the root cause. This is just to mention that we need to understand the limitations. Implementing online oil quality monitoring with chemical sensor monitoring, the lubricant fitness will help with early detection of issues related to water or dielectric constant, temperature, pressure, etc., that might indicate severe issues in the lubrication system. Now, chemical sensors can also detect more slowly developing issues related to the aging of oil. And when the lubrication system is a part of a large and complex installation, this is also a very efficient way to keep track of potential wear and tear. There are compelling reasons to monitor particles. Condense analyzes and provides cumulative particle trending per hour and indicates sizes and whether these are ferrous or non-ferrous to evaluate ongoing situations. When talking about non-ferrous particles, there are many types of sources. For example, an eroding seal that might contaminate the oil. Oil contamination can have many root causes by default. Some use cases that are sensitive, like turbines or hydraulic systems, tend to demand contamination monitoring. Condense provides sensor-agnostic solutions for different applications, as these are sophisticated needs. Then there are other applications in mining, for example, where particles are being introduced to the lubrication system, resulting from the production processes itself. This leads to situations where particle counting is not always the right method. And there, Condense offers oil color analysis to bring insights into the lubrication's health status. In some cases, these methods can take us from detection and risk mitigation to root cause failure prevention. For instance, an issue to address is the presence of varnish in lubricants. Varnish detection via the oil color is one of the standardized methods. There are ways to automate this with an online system. However, at an earlier stage, oxidation, which triggers varnish forming, can be prevented by timely detecting water in the oil with the help of chemical sensors, as we've discussed just now. And earlier still, one of the ways to prevent moisture from entering the system is to automatically track the proper working of desiccant breathers. Another example is that of automated lubrication systems, which are increasingly popular. These systems often come with local self-diagnostics, and this is one application for an online system like Condense to Automize. A typical example is an empty grease pod, yet other issues that require monitoring occur as well. For example, if a lubrication system is tuned for a bearing that also has a friction indicator applied, this will detect if an adjustment or other type of attention is needed. Which brings us to a point we have not yet touched, the integration with other systems. Routines and documentation or reports are commonly collected in the CMMS. In a majority of the cases, a demand for company-wide solution integration with a larger data storage and with a system where daily routines are managed is a key driver to implement a modern condition monitoring system or condition management system. Additionally, the system notifications can be set up in the CMMS to automatically trigger the lubrication pods need-based. Although Condense does not control processes, there is nothing to stop the user from setting this up on their end. So why automate these tasks? One prominent driver to change traditional routines is that a solid manual greasing routine still is no guarantee the lubricant reaches all the right places. Real-time or close to real-time monitoring not only indicates the optimal time for bearing greasing, as we've discussed earlier, but also almost immediately shows evidence of how effective the task has been performed. Taking physical samples is the traditional way of ensuring oil condition. Here we find two more motivating change drivers. Sampling intervals are often long and late detection might cause collateral damages. Manual sampling often holds monthly to multiple month intervals, and this might lead to mean-time failure. As mentioned, some issues, for example, in water-cooled systems, might lead to significant collateral damages if detected after several days or weeks. And then these manual processes do not build up any systematic data to learn from. For example, how to avoid potential issues on similar devices. Worth to mention, of course, that lab samples are often more precise and will perhaps never become obsolete. However, as meantime failures are common, by adding an online system, improved timing is often achieved. With Condense, we are experiencing all of this. We look beyond the monitoring to build prognostic tools and models that calculate and adjust the remaining useful life estimation to optimize the oil life cycle and condition. Now, wrapping this all up, ensuring proper lubrication is not a simple task. Lubrication is one key element of maximizing machine health and is sometimes undervalued. Timely detection of lubrication needs, oil contamination, and managing the quality of lubricants is a must. Online monitoring mitigates risks, allows learning from failures, and helps designing accurate reliability programs, and it supports these. with proper implementation of selected for purpose technology, which starts with understanding what to deploy where, when, why, and how. All this can be simplified and optimized for effectiveness. However, this requires a flexible and knowledgeable technology partner. Condense is delivered by a team with over 15 years of technical solutions experience and 5 years of global scale expertise in an industrial environment. We have learned and we continue to learn from the best minds in the market, and the knowledge behind the Condense solutions is unmeasurable in numbers. We distribute your intelligence and we help you leverage collaborative advantage. We thank you for your time. The next sensible step for you is to get in contact with us to see how, when, where, why, and with what we can help. Thank you.
Thank you, Erik, for this presentation and to explain us why we should go for online lubrication monitoring. There's one thing I was wondering. You said a one-size-fits-all approach doesn't work. Could you explain what you mean by this?
Well, Isabella, we see that often high-end plant or asset management solution is not cost-effective enough to deploy plant-wide. And the costs would be hard to justify for tier 2, mid-critical, and run-to-failure machines. On the other end of the scale, we see less critical machines being suitably covered by wireless and lower resolution IIoT systems. Suitable as these might be over there, these will not deliver enough value in time to react for mid to high critical machines. And we solve this dilemma by offering selected for purpose solutions all in one simple to use platform.
Okay, I see. All right, and also what I was thinking, when you were talking about friction detection with standard accelerometers, you said that this is just the first application for it. Do you care to explain a bit more?
Yes, we have developed this in cooperation with a Finnish university based on earlier research. And when first testing this live at customer sites, one of them notified us that our system gave false alarms. Condense reacted on issues that could not be detected by well-known handheld devices they used to cross-check, and we were confused at first as well, and we postponed the feature release. And then almost 3 months later, the issues started showing in the envelope. The handheld also picked up on it by then. And potentially this means that by looking at friction, we basically add 2 to 3 months to the Condense advanced forecast, which already was 3 to 9 months at the time. And now we also look at other implementations for this. Think about journal bearings and reciprocating equipment, for example.
Okay. And then you were talking about the second breathers and automated lubrication systems that integrate with Condense. Does this mean that you are open to third-party suppliers?
Yes, it does, as long as there's a business case, of course. Besides offering integrations with IT, maintenance management, and inventory systems, etc., we also have a third-party hardware and cloud interface. We connect with, for example, wireless sensors there, or connect with partnering cloud platforms. And this is just one of the key elements that make the Condense platform as collaborative as it is. Hence the term I used just now, collaborative advantage.
I see. All right, Erik, thank you very much for also for answering my questions and for explaining why we should go for online lubrication monitoring. For the people who haven't visited the Distance booth yet, please do so. They would be happy to answer all your questions. And if you are watching this expert talk online, you can find all contact details via the website and via their virtual booth. Thank you for watching. Bye-bye.
Right.